All right, here we go again. Some extra problems for solving two-step equations. Okay. All right, so I'm going to go through the process again. So once again, I look at my equation and notice that here's my variable term. Okay, I want to isolate that and get it by itself. So I look over to the side and I say, hey, there's a positive 9 here that I need to get rid of. Subtract 9 on both sides. I end up with 2h is equal to 12. So that's good. I got rid of that. I have my variables here, my constants on the other side. At this point, I realize, look, I have two h's, so I just need a 1h. So why don't I divide both sides by 2 so that I can eliminate that 2 up front and make it just 1h equals 6. Now I'm going to check my work. Plug it back in. Substitute. So 2 times 6 plus 9, does that equal 21? Well, I have 12 plus 9, which does equal 21. So there's my checking work. What happens if the variable is on the other side? Not a big deal. Here's my variable term. It's the term that has the variable with it. I look over to the side of it and I say, hey, this got a negative 5. Get rid of that. You're right. You add 5 to both sides. I do that and I end up with this. Okay, good. So I've now simplified this a little bit, but I don't want 6 p's. I just want one of them. So I divide by the coefficient, which is 6. Divide both sides. I end up with negative 2 equals p. So notice the difference between this and the one above. The only difference is the letters on the right hand side this time. And it doesn't matter where it's at. You have your solution. But you want to double check your work. So substitute it back in. And 6 times a negative 2 is negative 12. Negative 12 minus 5 is negative 17. And there's your proof that it does work. Okay, a few more examples. Okay, so here we go. The variable back on the left hand side. I want to circle or square up my variable term that includes the sign that's involved with it. So bring that with it. I say, okay, look. Other than that, I have this 12 here, so let's get rid of that. Subtract 12 on both sides. I simplify that. I say, okay, cool. Now I've got my variables on the one side, my constants on the other, so that's helpful. But I need to get rid of this coefficient. I need it to look like a 1. And if you recall from last chapter, the other video, it was about using the multiplicative inverse to get rid of this coefficient, right? So we multiply by its inverse, by its reciprocal. Flip it over, that's negative 5/3 on both sides. Okay, got to do some math. Now the lovely thing on this side is all this stuff is going to cross out. Let's leave you with 1p. On this half, you're going to do some cross canceling. I did that here. 3 and 39, do some math there, and you end up with 65. Okay, if you need extra help with this stuff, come see me and I'll help you with that, but I won't spend time in the video doing that now. And then I check my work. I go, okay, look, plug it back into the original problem, and I say, hey, I think the answer is 65. I plug it in. I do some simplifying. I find out that 12 minus 39 equals negative 27, so that works out great. All right, 2 more problems here. Once again, here's my variable term. Include the sign that it has, okay? So don't forget that part. Look to the side and say, hey, it's got a 6 next to it. Get rid of that 6, okay? So subtract 6 on both sides. Notice my first steps here are always adding and subtracting, right? Getting that constant over. I do that. I notice that my coefficient's negative 3 still, so I need to divide by that coefficient and end up with negative 5 as an answer. And I substitute. Okay, so I check to see, did it work? If I plug that in, this turns into 15, and 6 plus 15 equals 21. Great. Here's my last one. So I have Tavia. Tavia received a gift card for $50 to an online store. She wants to buy $8 bracelets. But if shipping costs $10 for overnight delivery, how many bracelets can she buy? Well, okay, let's try to figure this out. So there's price per bracelet, right, times the number of bracelets, and then you have to add in the shipping costs, and that should be the total amount. So I know that $8 is for the bracelets. I don't know how many bracelets yet, but I know that there's going to be $10 shipping cost, and the total that she can spend is $50. So I go ahead and set this up. Notice right here, here's my variable term. I leave that alone. Get rid of the shipping cost first. Say, look, if I got $50 and 10 of it is in shipping, that leaves me with $40 just for bracelets. Then I can divide by my coefficient, and I find out that, Tavia could afford 5 bracelets and have them shipped overnight, all for $50. All right, I hope that helped out. Again, this video is going to help you a little bit more, and make sure you have questions for me in class.